So far, we have discussed the topic average velocity and average speed, right? So we did 10 questions out of it. I have given you almost the coverage of all possible questions, which I could frame in keeping the number constant as 10. See, the more you practice, the more variety of questions you get. But I would say this is the bare minimum to know these many problems. Having said so, let us now move to the next topic, which is instantaneous velocity. So those students who have attended the theoretical lectures, you would have got now a clear idea about the difference between average velocity and instantaneous velocity. Okay, so this is the first question. It goes like this: a particle moves along a straight line OX at a time t. The distance x is given by 20 plus 6t square minus tq. How long would the particle travel before its acceleration becomes zero is the question. See, there's one thing that you need to understand here, which I would say is the relationship between differentiation of distance with respect to time. See, what is given here? X is given, right? So when you differentiate x with respect to time, what do you get? You get velocity. When you differentiate velocity with respect to time, or in other words, when you differentiate velocity, which is basically dx by dt, what do you get? You get the next term, which is acceleration, right? So acceleration, in other words, is nothing but the second derivative of distance, right? So what is acceleration? Acceleration is the second derivative of, I beg your pardon, second derivative of not distance, it is displacement, right? In which case, we can write that if acceleration becomes zero, then the second derivative of distance also becomes zero. Now, what is second derivative of distance? It can be written as d by dt of x is equal to 0, which further goes like this: d by dt of, what is dx by dt? Is d by dt of x. What is x? X is given as the equation 20 plus 6t square minus t cube, and this is equal to 0, right? So let us now differentiate. So we'll get d by dt of, what is d by dt of 20? It is 0. D by dt of 6t square is 12t minus d by dt of t cube is 3t square. Now, if you have any doubt in using differentiation and integration, please don't feel, that shouldn't be a factor for demotivating you. It is okay. It is okay that you don't know it for the time being. I will give the link for the description. I will give the link in the description for the video series. I uploaded 10 videos which will include all the applications of differentiation, integration, and vectors in physics. Okay, you can go through them and then come back to this question. So now what will be the second derivative? Will be d by dt of this. This will be equal to 12 into, okay, let me just write down the step in detail, minus 3 into d by dt of t square, which is equal to 0. Now what is 12 into d by dt of t? It is 12 into 1 minus 3 into 2 into 2 raised to 2 minus 1 is equal to 0. So it becomes 12 minus 60 is equal to 0, which implies 12 is equal to 60, and therefore t is equal to 2 seconds, right? So the object will reach, so the acceleration would become 0. So acceleration is equal to 0 at time is equal to 2 seconds. Now, what is the question? Is the question to find when is the acceleration becoming 0? No, it is asking how long would the particle travels before the acceleration becomes 0. Okay, let us now try to understand how we'll do that. See, the given equation is x is equal to 20 plus 6t square minus t cube. It is also given that when acceleration is equal to 0, The time is in 2 seconds, right? Now, if you try to understand this using a diagram, if suppose the body is moving from A to B at time t is equal to 0 to t is equal to 2 seconds, we can say that at this point the acceleration was 0, right? So, acceleration is equal to 0 when t is equal to 2, or when the object has covered the distance AB, right? Now we can say that distance AB is what we need to find. So distance AB is basically equal to distance covered at time t is equal to 2 seconds minus distance covered at time is equal to 0 seconds. So basically the distance time relationship is being evaluated at two different points. Now, what is distance time relation? What is distance at t is equal to? It is 20 plus 6t square minus t cube at t is equal to 2 minus 20 plus 6t square minus t cube at t is equal to 0, right? So this is equal to 20 plus 6 into 2 square minus 2 cube minus 20 plus 6 into 0 square minus 0 cube, which basically is equal to 20 plus, what is 6 into 2 square is 24 minus 8 minus 20, right? So this will give you 20 plus 24 is 44, 44 minus 28, which is basically equal to 16. So the required distance is equal to 16 meters, in which case the correct option is option A.